All right, 13.11 is all about naming a shape, given some coordinate points, and you get to prove it using some math that you know. All right, so let's get right to it. So, by the end of today, by the end of this lesson, you should be able to graph some points, use some math that identifying some slopes of some lines, and knowing how those compare those slopes, and identify, if their lines are congruent or lines are parallel or perpendicular, and then also knowing what you know about calculating the line distances and comparing those line distances, and using those two things kind of recognize um, if the shapes are like what the shapes are, coupling that with what your knowledge about shapes. All right, so let's get to it. All right, so here we go. We have a line. We have this graph number one. We're just go ahead right off the bat. We can tell that we have a quadrilateral. A quadrilateral, because we have 4 points to plot. Let's just zoom in and plot some points here. Carefully plot points, because number one mistake you can make is plotting these points wrong. So point T is 0 and 8, so it's way up here. This is point T. All right, and then point R is -4, and then 4 all the way up there. That's point 8. And then we have point B, which is -6 and -2, which is kind of like down here. Sorry, this is point R. This is point B. And then we have point S, which is -2 and 2. All right, so that's us plotting those points, and we'll go ahead and this is S. That's S. Go ahead and connect those dots like that, and like it's a skinny shape. That's a skinny quadrilateral. And we'll kind of look at what we got going on. Obviously, it doesn't look like we have any perpendicular lines, and we don't have any. Sorry, I mean we don't have any parallel lines, and it doesn't look like we have anything close to a perpendicular line either. Right away. Oh, wait a minute. S. I plotted S wrong. S is not there. S is incorrect. S is -2 and 2. Makes it even skinnier. Well, I caught that early on. S is -2 and 2. Okay. Alright, there we go. That looks better, I think. That's S. S is -2 and 2. Almost made an error there. Okay, so that is our S. Okay, so now we have some lines here, and let's see if we have anything that looks like they could be, well, these look like they might be parallel, and these look like they might be parallel. So let's see if we can figure out the slope of RB and TS. Alright, so the slopes, MB, the slope. Remember M, it's the change in Y over the change in X. Okay, so our slope of we'll do BR first. Move that down a little, I guess. Give me some space to write neatly. So the slope of BR, why did I write it like that? I don't know. Slope of BR BR is going to be my change in Y. So B is -2 minus R so my change is going to be -2 minus R minus 4 equals -6. Alright, so my change is going to be -6. Okay. And my change in X is going to be -6 to -4 minus 4 negative equals -2. Alright, so that makes sense. I got a positive slope, right? So that ends up being a plus 6/2, which is +3. That's a +3. Okay, how about TS? TS, slope of TS equals my change in Y. So T starts at, it started at S. My T, I mean, I could start at T and it would end up the same, but let's see, 8 minus 2 is 6. To make sure I do it the same. It's positive, right? And then 0 minus 2 that's also 2, right? So that absolute value is 2, right? So it's going to be equal to 3. Right, so my slope is also positive and it's 6. Right, it's a lot easier to do this with the picture value, right? Because you can be like, oh, this is up and down, and now I can just this goes from left. We're going from right to left. It's positive, so I can say, okay, that's easy. Going from right to left, it's going upward, so it's positive, and I can just look at the absolute values and I can take it, right? So it's a lot easier to look at it and be like, yeah, it's a positive slope, so I can just take the absolute values of my change and go for it. So how about the slopes of, it's funny here, all of my slopes here are positive. That's crazy. Okay. All right, so here we go, RT slope, my change in Y for RT, R goes from 4, it looks like it's 4, and then it looks like it's 4, so it's 1. Right, so that's a 1-to-1 change. So my slope is 1, and look at it. You can see it goes right across the block. So that makes sense. And if you look down here, it's the same thing. It goes right across the block. So if I look down at RS or BS, my slope for BS should be a 1-to-1. Right, so -2 to 2. That's 1. Okay, let's see. That's 4. And that's 4, so it's 4 to 4, which is 1. All right, so these are parallel, and these are parallel. All right, so at least I have a parallelogram. Okay. I wonder if it's a rhombus. I need to see if this is a rhombus to see if these are all the same length. Okay, so if these are the same length, if all of these are the same length, this would be a rhombus. So I gotta check to see if these are the same length. All right, so RT, I know that these are gonna be the same length because that's the property of a parallelogram, and these will be the same length. So that's a property of a parallelogram, right? Like when two parallelograms do this, like that's a property of a proper like that, right? But it's like because it's not a trapezoid, right? But and I know that this and this will be congruent, and this will be congruent. But that's neither here nor there. But I need to know if RT and BR are congruent. All right, so what is the length of RT? Well, this is going to be the square root of my changes in x's, my changes in y's. All right, so what was my RT change in x? It was 4. So 4 squared. And what was my RT change in y? It was 4. RT change in x and change in y, so it's 30. So 4 squared plus 4 squared equals 32. Is the square root of 32, which is 16. Let's see, 16 times 2. 16 times 2 is, so it's 4. 32. 4 squared plus 4 squared equals, yeah, so it's 32 divided by 2 is 16, so it's going to be 4 times the square root of 2. Yeah, it's 4 squared root of 2. 4 times the square root of 2. All right, so that's that one length, because if I take my square 16 and if I square 4 and I multiply by 2, yeah, that's right. Okay. All right, so then what is the length of RB? Well, my change in y for RB or BR was 6, and it was plus 2. Both of those are squared. All right, so 6 squared plus 2 squared equals 40. The square root of that is, so that's 10 and 4, so that's 2 square root of 10. All right, so yeah, they're not the same length. So not a rhombus, so this is a parallelogram. This is a parallelogram, and that's it. Nothing more fancy beyond that. And I can say that because opposite sides are congruent. Well, I guess I can prove that, don't I? Are parallel, right? Let's prove that they're congruent. I mean, you can see that they're congruent, right? BS and RT do the same math. They're congruent, right? RT and BS, because BS length would be BS and RT. This would be square root of 4 squared plus 4 squared, because the change in x and the change in y are the same. And then RT would be 4 square root of 2. Right? And then so our TS is 6 squared over 2 squared, which is the same. So those are, and so the property, so opposite sides are congruent and same length and congruent. Okay. So so I can say, I'll say ST, same slope. I'll just say ST is equal to BR. Actually, that's going to be no. ST and BR slope equal. And same thing with RT equal to BS, RT, and BS slope equal. So that is what I'm going to say for that one. So that is a parallelogram in use. If you want to pause it right now and kind of take a look at it and get some notes, now is the time to do it. Okay? Let me move on to something else. That has 4 points. I don't want to do that one. Here's one that has 3 points. Let me take a look at that one. Let's see. I like 7 and 7. Let's do 7 and 7. Let's do this one. That looks fun. All right. So let us plot this one here carefully. Maybe I won't make a mistake this time. All right. So -7 all the way up to 7. That is H. This one is done. Okay, -2 and all the way up to 5. And that is done. Okay, -4 and 0. And that is done. So -7, 7, -2 and 5, -4 and 0. All right, that looks like it is correct. This is J, and this is K. Let me connect some dots. I like to find the slopes first, because if I document my work well, I already have my change in y and change in x to find the lengths. But I guess if you do that, if you document the change in x, y well to find your lengths, it'd be easy to find the slopes too. But notice the documentation is what is important. Okay, so you don't have to rework. Rework takes time, and time is precious on exams. All right, so well, it looks like I have something pretty close to a right triangle. Okay, so let's see if this. Let's check out some line segment lengths. Okay, I mean, I could prove this thing is perpendicular, and or I could prove this is a right triangle in a couple ways. One, I could find the lengths of all these 3 sides and check Pythagorean's theorem and see if it works with the lengths. I could also check the slopes of this one and see if it's the negative inverse. So I'm going to do it the second way. All right, so what is the slope of HJ? So slope, remember, it's the change in y over the change in x. That way I can have the lengths too later. So HJ slope, okay? HJ starts at, it's a negative slope, okay? It's a negative slope, so I'm just going to go ahead and say that. Absolute value between the change in 7 and, oh sorry, I'm looking at y values, right? So it's 7 and 5, it's going to be -2. My change in x is going to be -2, and that's going to be -5. That's going to be 5. So it's going to be -2 change in y's and 5 changes in x. It's -2/5. Okay? So like guys, I could do the length right now. Right? So this is going to be 2 squared plus 5 squared, right, equals 2 squared plus 5 squared equals 29. It's going to square root of 29 equals the square root of 29. Okay, so I figured out the slope and the length all in one step. Okay, how about JK? JK, it's going to be a positive slope. It's a positive slope. And my change in y is 5. It goes from 0 to 5. And my change in x goes from, it's from 0 to, that's 2. It's 2. All right, so it's, yeah, they are definitely opposite reciprocals, right? Because one's -2/5 and the other one's 5/2, and hey, guess what? Yeah, the equation is going to be the same. It's going to be the square root of 2 squared plus 5 squared. Right? Maybe it's -2 or whatever, but when you square negative, it's going to be positive, so it doesn't matter. Right? So it's going to be the square root of 29. Square root of 29. Okay, well, I can figure out this length easily. 29 squared plus 29. Let's do the square root of 29. 29 square root squared is 29. So I guess I do 29 plus 29 equals, take the square root of that. This is the square root of 58. Well, it's 58 divided by 2. It's 29. This is square root of 58. This is the square root of 58 is the length of that. I could figure it out with the change in x over the change in y, but I don't want to. Because I don't need to. Because I just did it with Pythagorean's theorem. I can figure out the slope of HK. HK equals change in the slope in HK equals, let's see, it's going to go down. It's going to be negative because it's going down, and it looks like it changes in 3. And it goes, oh, that's the X value. Oops. It changes in, goes to 0, starts at 7, changes in 7, goes to 3. All right, so it's 7/3, not perpendicular to anything, which makes sense because it's a triangle. So it's negative 7/3, but whatever, who cares? So, I wonder what the angle is, just out of curiosity. I wonder what type of triangle. This is 90-degree angle. Figured that out because of that. Well, I wonder what that angle is. I wonder what this angle is. This is, if I wanted to figure out this angle, and this is the square root of 29, that's the square root of 29. Wait a minute. These are the same. And the only way in a right triangle that these are the same is that this is a 45-degree angle, and this is a 45-degree angle. So if I do, let's see, if I do opposite, let's do the tangent. Or whatever, we'll do this, let's do the tangent. Yeah, sure, opposite over adjacent. 29 square root divided by 29 square root is 1. And if I do the arc tangent of 1, that's 45 degrees. How about we do the sine? The sine is opposite over hypotenuse. Let's do 29 square root divided by 58 square root equals, and let's do the arc sine of that is, hey, that's 45 degrees. How about the cosine? Let's do the cosine. Let's do 29 square root divided by 58 square root equals, and let's do the that's the arc cosine of that, and hey, look, that's 45. Man, that's crazy. Anyway, well, if this is a 45, 45, 90, this is a 45, 45, 90 triangle, making it an isosceles right triangle, also a 45, 45, 90 triangle. And I can say that because H, J, and JK are congruent and perpendicular because they have negative, opposite, and why did I put a squared? And reciprocal. Oh, actually, I wrote that wrong. I shouldn't do that. Reciprocal slopes. Sweet. You could also say Pythagorean's theorem or whatever, but that works too. All right, that was a fun one. I really like that one. So what if what kind of classification is a triangle that doesn't meet any? It's just a random triangle that doesn't meet any classifications. There's nothing congruent about it. It's just a random triangle. It's not a isosceles triangle. It's not an equilateral triangle. It's just like a random acute or obtuse triangle. It's called a Scalene triangle, SCALANE triangle. I would go ahead and put in there like obtuse or acute, but I think the answer might be SCALENE, Scalene triangle. Maybe it's Scalene triangle. I don't know. I'm just a geometry teacher right now. Okay. So anyway, hope that helps, and you guys have a great day.